All right, so exponential functions. So far, we've learned about many different types of functions. Does anyone care to share any of the functions they remember learning about? What functions have we learned so far? Spencer. We learned linear, which is this is the parent function here. We learned quadratic. This is the parent function for quadratic. Absolutely. We learned about absolute value functions, which is this parent function here. What other functions have we learned about so far, Caroline? Oh, we got linear up here. You have any other ones? Cubic. We learned about cubics. So we have linear, quadratic, absolute value, cubic, in. Radical functions, which is last chapter. So we know how to deal with functions, yes. Quintic and quartic, so we would just change the exponent to 4 and 5. And so now we're going to jump into exponential functions. And the parent for the exponential function is this one here. Let's go there. This is what we're doing in chapter 7. Y equals b to the x. What is the difference between every function we've learned so far and the one we're about to explore today, Maria G? This is true. What else is the difference? Spencer. X could be anything. Same with all the other ones. But what else is the difference? Ian. Exactly. The x is in the exponent. So up until now, the x was always part of the base. And it's very easy to solve those types of equations. Now the x is in the exponent. And now we're going to have to solve for x with the variable being an exponent. All right, so that's the difference between exponential functions. Is that clear? All right. Also, with all of the other ones we've done before, the general form, so say we are talking about, say we're talking about quadratic, the general form would be y equals a x minus h squared plus k. If we had the general form talking about transformations, absolute value would be y equals a, absolute value x minus h plus k. Last week we took this one, it's y equals a radical x minus h plus k. The same thing with exponential functions. Hopefully, as you're starting to realize, everything is exactly the same. We just put an a in front, so y equals a b to the x minus h plus k. Everything is very similar. Hopefully, you can see the similarities and the differences between these functions. K would be up and down, h would be left and right. We're not going to talk about these transformations until the last part. We always save the transformations to the end. It's not going to be anything new, just like every other time. But what we do have, we'll leave the a here. So the general form, this is the parent function, y equals b to the x. But the general form is y equals a b to the x. A, as in every other function that we've done so far, what is a going to be here? What does a represent? Stretch or compression factor. So same thing here. Y equals ab to the x. A is just your stretch or compression factor. Is that clear? All right. We're going to identify if an equation is growth or decay just by looking at the equation. If b is bigger than 1, if b is bigger than 1, then we have growth. If b is between 0 and 1, if it's between 0 and 1, it is decay. B is always positive, B is never negative, and B cannot equal 1. So this is how we could tell if it's growth or decay. What A tells us, that's the number in front of B. A tells us what the y-intercept is. So for example, I'm going to write a quick exponential function on the board. I just want to see if you could identify which number represents A, which number represents B. So again, y equals ab to the x is our general form. Say I say y equals 3, 5 to the x. What value is a? What value is B? Straightforward, yes? And if B, if it's bigger than 1, it's growth. If this number is between 0 and 1, it's decay. Is that clear? One more. What value is A?
0.24.
What value is B? 1.3. Exactly. So it doesn't matter if we have an expression here in operations, anything in parentheses being raised to the power, all of this entire factor is our B. Does that make sense? That entire factor is B. And this would be A. Got it? All right. Maria G, is this growth or decay?
Growth.
Why?
Because it's 1.3, which is bigger than 1.
That's it. Good? All right, real quick, let's see if you could answer these questions. Let's go rapid fire. Number 7. Growth or decay, 2 parts to the question if you read the instructions. Determine if it's growth or decay, and what is the y-intercept. The y-intercept is always the A value. Antonino.
I'm going to say it's decay.
Okay.
And y-intercept is 0.99.
There you go. Decay, y-intercept is 0.99. Ian, 8. Okay. Straightforward, yes. How about number 12? 12. 12. Yajay. Yajay. Yes. Does everyone see why it's growth? Can you explain why it's growth?
Because 6 over 5 is 1.
6 over 5 is the fraction. If you're not sure if it's bigger than 1, convert it to a decimal, 1.2. Or a mixed number, 1 and 1.over5, which is greater than 1. Do we need to do any more of these, or can we move on to the next part of the lesson? All right. Now we're going to model. We're going to model exponential growth and decay. Here we have a formula for exponential growth. And over here is the formula for exponential decay. What I want you to take away from this is that this entire quantity, this is B. After you simplify this quantity, that is your B value. That's your growth or your decay factor. Everyone see that? All right. A is the initial amount. You've all seen this in Algebra 1, yes? A is your initial amount. That's the amount you start with before you calculate your growth or decay factor. R is the rate. Please make a star here. Your rate has to be converted to a decimal. Most of the time, it's going to be written as a percentage. You have to rewrite it as a decimal before you put it in the formula. I just want to make sure everyone knows how to write a percentage into a decimal. Say we have 0. Say we have 95%. What is 95% written as a decimal? Does everyone remember how to do that? If you don't, that's fine. Just make sure you pay attention now. Ian, 0.95. Ian, can you explain how you did that? Exactly. There is a decimal point here. 95 is the same as 95.0. Do you all agree? The decimal place is right there. To write this as a decimal, move it 2 places to the left. After we move it 2 places to the left, the decimal point is right here now, making this 0.95. So you have to take your percentage, rewrite it as a decimal before you could use these formulas. Is that clear? All right. Now we're going to create some models. I have 2 questions that I want to ask you before we do some algebra here. And make sure your calculator's out. We're going to need those in a little bit. How do we write a model? You've written models before. When we did linear regression, those were all linear models. Do you remember talking about linear models? So how do we write a model? It's very important. Most people don't get this idea down, and they're a little bit confused. In order to write a model, you have to substitute a numerical value for all variables except for what? You have to substitute a number, a numerical value for every single variable except for what? Y. That's it? Yeah? That's not correct. Except for Y and X. So to write the model, substitute a numerical value for every single value except for Y and X. Leave Y and X in your equation. Do not put a number for X. Do not put a number for Y. Leave them as variables in your equation. That would be a model. That would be your model. Are there any questions about what I'm talking about when I ask you to write a model? Question number 2. What are models used for? What did we use models for in the past? Think about linear regressions. When we created a linear model, what did we use that model to do? The primary function for a model is to make a prediction. So every time you're going to be asked to make a model, please remember this. Whenever you make a model, it could be a linear model, a quadratic model, an exponential model, a cubic model. Every time you make a model, the reason why you're making a model is so you can make a prediction. All right, example number 1. A population of 1,236,000 grows 1.3% per year for 10 years. What is the model? I want you to create a model. So first we take the formula, since the example says growth. Since we know we're dealing with growth here, we take the formula, which is here. This is the formula for growth. And now we must create a model. To create a model, we have to substitute a number for every variable except for Y and X. Haley, do you have the model?
Would it be Y equals 1,236,000 and then parentheses 1 plus 0.13
0.013
and then
X. So when you make the model, do not put a number for X, do not put a number for Y. Just leave Y and X, but substitute everything else. This is the model. Once you have the model, put this into your calculator, Y subscript 1. So you're going to always make the model first. Make the model first, then put it into Y subscript 1. So in your calculator, put 1,236,000, parentheses 1 plus 0.013 raised to the X power. Can everyone do that now? Once the model is in your graph, look at the table. The table will give you every answer you need to make a prediction. So the question is asking you, what is the population after 10 years? Years is X. So they're asking you, what is Y when X is 10? Does everyone see that? What is Y when X is 10? So if you look at your calculator, the table, go down to 10. When X is 10, what is Y? Sure, that's correct. That's the table rounds it. So if you just highlight it, and look at the bottom, you'll get the exact answer. Is everyone looking at it now? At 10, highlight this Y value, look at the bottom, and it'll give you the exact number. What number do you see there? Angelina? Yeah, not the decimals though. Do you see this number right here? Yeah, what is that? Yeah, 1,406,413. Is that what everyone sees on the calculator? So the correct answer is first we have the model, which is the model Haley told us. Once you get the model, put it into your calculator, look at the table, and then you can make predictions. Next example, and then we'll be done here. What do you think is going on here? A new car that sells for $18,000 depreciates 25%, each year. Yes. So here's a vocabulary word you must know. You will see this word over and over again. You need to know that depreciates. Depreciate means to lose value. In other words, it means to decay. So now we'll use exponential decay, which is y equals a1 minus r raised to the x. Decay is minus r, growth is plus r. You have the model?
Yeah.
What's the model?
Y equals 18,000, parentheses 1 minus 0.225 raised to x.
All right. And once you get the model, you put in your calculator already? All right. What'd you get for the answer?
5,695.
5,695 is correct. And 31 cents. Does anyone have any questions? All right. You've got 20 minutes to get this assignment done. There are two pieces to this assignment. One is additional vocabulary support. The post for today had two attachments. This is the second attachment from the post for today. This part of the assignment is from your textbook.
What was the answer to the one we just...
Good?
Yeah, I got it.
All right.